Hello viewers, in this video tutorial we'll be looking at this question, how to find the range of piecewise defined functions. So we have two examples here to look at in this video. So let's go to example one. So we want to find the range of this piecewise defined function. So we will apply two methods, just like I think the previous video. Okay, so let's say method one. Now, method one, we will use as similar to what we did in I think in the previous video on how to find the range when you have a restricted domain and all. So we'll use that idea here. So if you look at this now, this is piecewise defined function. So we have like two pieces here, one, two. So let's call this first piece y1, and this one we can call it what? Y2. So let's work with y1. So y1, it's what? It's just y1 is just minus x squared, and this y1 has its own domain, so let's call it d1, and this is nothing but what? X less than 1, so it is from minus infinity to 1 open. Okay, now let's find the range for this function, just this simple function. Now what do we know? We know that x squared, usually we said x squared is greater equals to what? Is greater equals to 0. Yes, so this is true even in this domain. Why? Because x equals to 0 in this domain. So if x is equals to 0, then we'll have equality 0. So with this, we can now multiply by what? By negative. So you have minus x squared is less equals to what? Less equals to 0. Then what is minus x squared? Minus x squared, as you can see, is nothing but our what? Our y1. Look at it. So it means that y1 is less or equals to what? 0. And so what does this mean? This means we are going from minus infinity to 0 close. Okay. Now, in this case, if you look at this first domain, D1 is not a restricted domain because you have what? You have minus infinity. So you can see also the range here is not restricted because you have minus infinity. So it's fine. You don't need to look for any minimum value. No, this is okay. So it means that we can say our first range, R1, let's call it R1, is from minus infinity to 0 close. So we're done with the first function, the first piece. Now let's go for the second piece. The second piece, which is, let's call it now Y2. So Y2 is absolute value of x minus 2. And what is the domain in this case? Let's call it D2. D2 is from 1 close to infinity, right? All right, so what do we know about absolute value? We know that what? The absolute value of x minus 2, this is still going to be greater or equals to 0. Yes, this is still true. Absolute value is always non-negative. And why do we have equals to 0? Because if in this domain, 0 is 2 is in this domain, right? 2 is in this domain. So at 2, this will become 0. So absolute value of 0 is 0. And now this is nothing but what? This is actually your y2. This is our y2. So it's simply saying that y2 is greater equals to 0. Remember in my previous video, I think in the first part of of range, we said anytime you have an absolute value, you can use the fact that an absolute value is greater equals to 0. If you have an even power, also is greater equals to 0. If you have an even root, every is also greater equals to 0. So that's what we're using here. So that's why we have this first statement that absolute value of x minus 2 is non-negative. But this is easy here because this is exactly y2. But assuming we have like maybe plus 1 here, then I have to add 1 to both sides of this inequality. But we're fine with this one. So this is just what we have. So what does that mean? It means the range for y2 here is just going to be what? It's just going to be from, let's call it here, our r2 is just going to be from where? 0 to where? To infinity. Is that okay? So we're done. We have R1, which is coming from the first piece, and this is R2 coming from the uh, from the second piece. Okay. So what can we do? It means that our range, remember the range of the function is going to be the range coming from R1 and the range which is R1 and the range R2, which is coming from the second piece. And this is nothing but what is R1? R1 is minus infinity to 0 close union. R2 is also what you can see from 0 to infinity, if you like. And so what does that mean? What can we say about that? So this is what we have. Okay, so if you look at this simply means that what? You are going from where? Minus infinity to where? To infinity. So the range is going to be the whole of what? The whole of R. All right. So let's see using the second method, which is the graphical method. So now, how do we graph this? Here we're going to use point. We can use transformations to graph it, but it's fine. Let's use point. This is our function f of x. Remember, it's a minus x squared when x is less than 1, and its absolute value of x minus 2 when x is greater equals to 1. So here, let's have a table. What does this mean? We'll pick some points. Okay. And here we can have the values of y. Okay. So these are the values of x. So we just pick some points, and here we can call it the value of y just for the first piece. So we can pick some values of x that are less than what? Minus 1, less than 1. So we can start from, say, minus 3. We can go with minus 2. We can go with minus 1. We can go with 0. Then we can stop at where? At 1. But don't forget, we know here x is not equals to 1. So we put what? We put an open circle here. Now, so let's find the corresponding values of y. If x is minus 3, y will be, put minus 3 here, you have minus 9. And here will be minus 4. And here is going to be minus 1. If you put 0, you'll have 0. Okay, then if you put 1, you're going to have minus 1. But since the value of x is open here, the value of y also has to be open. We will see the importance of that. Now, for the second piece, let's also take values. So here, our x is what? Is greater or equals to 1. So we can start from 1, 2, 3, 4, 5. We can have so many values, And here, the y here, if you substitute x equals to 1 into this piece, you will have absolute value of minus 1, which will turn out to 1. If you substitute 2, absolute value of 2 minus 2, this will be 0, this will be 1, this will be 2. And if you put x equals to 5, you have absolute value of 3, which is 3. All right. So we will use this table to draw the graph. Okay. Now on the x-axis, you can see that the most negative we have here is minus 3. So we can decide to start from minus 3. That's fine. And let's say minus 2, minus 1, 0. And we can have 1, 2, 3, 4, 5. But if you look at the y values we have, the smallest y value is, I think, is minus 9, right? Minus 9. So let's use a scale of, let's say, 2, 2 on the y-axis. So this is minus 2, minus 4, minus 6, and let's say minus 8. Then let's have minus 10 as well. Okay. So here, let's finish with the first piece. The first piece is when x is what? When x is minus 3, y is minus 9. So if x is minus 3, so y is minus 9. So it's in between minus 8. So this is the point. Now, for x equals to minus 2, we're here. From minus 2, we should go to minus 4. So we have something this way. Then for minus 1, we're still at minus 1. So if this is minus 1 is between, no, minus 1 will be somewhere here. So yeah, let's say somewhere here. This is minus 1. The minus 1 here is somewhere here. All right. Then the next one is 0. When x is 0, we have 0. So this is the point. Then, if you look at it, when x is 1 here, we're on the last point here, it's going to be minus 1. So it means you're back down here. And this is the minus 1, somewhere here. All right. So what do we have? We have, as you can see, this is going to be a curve, something like this. Then it will stop here. But now, if you look at this point, at 1 here is open. So the y value 2 has to be open. So here is going to be open here. So please let me move this down a little so that we have, so let's say this is minus 2. So this is minus 1 here. Minus 1. Okay. So we're done with the first piece. Now for the second piece, we will use the values coming from this table. When x is 1, so we are still here. If x is 1, y is 1. So we're somewhere here. So let's say this is 1 here. Then when x is 2, y is 0. So we're here. We're here. When x is 3, y is 1. So we're back here. When x is 4, y is 2. So we're a little bit up here. And when x is 5, y is 3. So 3 is between 2 and 4. So let's say somewhere here. Now you can see this is taking the shape of an absolute value. It's a v. V shape, so it's supposed to be something like this, right? So let's adjust this point here and also this point. Okay, then we have this also here. Now what we notice is that what you can see at 1, remember at 1 we open it in the first piece, which is here, right? But at x equals to 1, we're actually in the second piece, so here needs to be closed. So this is closed, while it is open down here. So this is the second piece, which is absolute value x minus 2, and this is what the first piece. Now we're done with the graph. And as you can see from this graph, if you want to take the range, you see, remember here, this will keep going, right? Mhm. And this also will keep going to infinity, because here we can take values like 6, 7, 8 continuously. Here, remember we're supposed to take values x less than 1, but we only started from minus 3. Someone can start from minus 10, minus 12. So that is why this has to continue going downward. So, and as you can see from this, the value of y, it's simply what? The value of y will be from where? Minus infinity, right? From minus infinity up to here is what? Is 0, right? But we also have from 0 here, all these are values of y going to infinity. So at the end, you're going to have minus infinity to infinity as the range of the function. And this is the same as what we got here when we apply the first method. All right, so let's move to the second problem, which is this. So we'll still use these two methods. Now, so we consider the first piece. Now for this first piece, we will call y1 to be what's x squared. Then I will call d1, which is the first domain, so which will be from minus infinity to 0 open. Okay. Now, what do we know about even powers? We talked about how finding the range of what? Even powers, right? You said you set x squared to be greater equals to 0, right? Yes. But in this situation, we cannot say x squared is greater equals to 0. Why? It's a true statement, yeah, but here there is no 0 in this domain. So since there is no 0 in this domain, it means we don't need to go to get to where? To 0. So x squared greater than 0, it's fine. Unlike in this case, the first case, you see, here we said equals to what? 0. Because in this domain, 0 is in this domain. So if you want to apply this first method to a piecewise defined function, you need to be a little bit careful, look at your domain carefully before you make this kind of inequality. So with this, we can do with this. This is true. But now, what is this x squared? X squared turns out to be our y1. So our y1 is greater than what? 0. So what does that mean? This simply means that the range R1 is going to be from where? 0 to infinity. So this is coming from where? The first piece. All right. So here we have three pieces actually. So the second piece, take y2 to be x plus what? Plus 2. But now domain is restricted. 0, 3. This is a restricted domain. Okay. Now, how do we find this type of function? If you look at this function, this is like a polynomial function. So how do we find the what? How do we find the range of a polynomial function? If you remember, I think in the part one video, we said you solve for x in terms of what? Y. So now, if you try to solve for x in terms of y, this is say x is equals to what? Y2 minus 2. So this is a polynomial also. So the range is going to be from is supposed to be from minus infinity to where? To infinity. But now, can we go from dice, how do? We solve for x in terms of y and we find the domain of this, right? Okay. This is a polynomial. So the domain is what? Is minus infinity to infinity. But can we go from minus infinity to infinity given that the domain is restricted? So since the domain is restricted, then we cannot say minus infinity to minus infinity in this case. So we need to know what will be the maximum value and also the minimum value of this function here in which interval? In this interval. Now, if you look at this function clearly, it's simply a line with a positive slope. So it means it is rising from where? From left to right. Now, since it's rising from left to right, we know that what the minimum value will be achieved at where? At zero. So if you have something like this, let's say you have this. This is a positive is a line with a positive slope. So the minimum value will be somewhere here, while the maximum value will be up here. So this tells us that to find the minimum value, or let's say the minimum value of y2 is going to be at where? At x equals to what? 0. So if you put x equals to 0 here, you're going to have what? So let's say the minimum value of y2 is at where? X equals to 0. And so y the maximum value of y2 is at where? At x equals to what? 3. So it means the range, which we can say, call it R2, is going to be what? It's going to also be closed since the what? Since the domain is closed. At x equals to 0, this will give you, the y2 will give you what? Put x equals to 0, you will have 2, right? And as x equals to what? 3, at x equals to 3, what do you have? You have 3 plus 2, which is what? Which is 5. So this is our R1 coming from the first piece, and this is R2 coming from the second piece. All right. Now, let's go to our now let me just say something quickly. This is a line, and we know it's a positive line. So it's something like this. But if it's a negative, it's going to fall in this case. So it's decreasing. So if it's decreasing, then this will change. If it's decreasing, then the minimum value will be what? The minimum value will be achieved at the end point here at 3, while the maximum value will be achieved at where? At 0. So take note of that. Whether the function is increasing or decreasing, you should have an idea of that. Okay. Now, let's go for the third piece. The third piece is what? Y3, and which is nothing but just a constant. So it's a constant, y equals to 4. And in this case, our D3 is nothing but from 3 open to infinity. So from 3 open to infinity. So what does this mean? This simply means that what? This is a constant. So the range, our R3, is just going to be the constant 4. So if you want to find the range of this function now, it's going to be the R1 union what? R2 union what? R3. But what is R1? Is from 0 to infinity union what? This is union R2. R2 is close 2 to 5, and R3 is just 4, right? But if you look at this carefully, the closed interval 2 to 5 is already inside 0 to infinity. 4 is already also inside. So if you take the union, it's just going to be what? Just going to be 0 to 0 to infinity, because 0 to infinity cover all of this one. So that is the range. Now, for the second method, we need to graph. But now I will just go directly without using test points. You can try to use point as well. So what I mean by point, you take some points less than what? Zero, take some point and draw your table. Take some point also between 0 and 3, draw your table, and take some point greater than 3. Uh, this one, just the way we did before, you take some point here, right? You take some point here, then you take some point here as well. But I will not do that in this for this problem. It will work perfectly fine. Here, I just want to use transformation, right? Yes, transformation. Let's use transformation and graph this quickly. If you look at this, this is just the first piece. Look at the graph of what? X squared. We all know that the graph of x squared is something like this, right? But for the first piece, we are told that x is what? Is less than what? Is less than 0. Now, since x is less than 0, it means you don't need the positive part. So let's remove the positive part because this part means x is greater than what? Than 0. So x is this. And you can see that there is no equality at x. So what do? We have to open this. So this will keep going. So we're done with the first piece. Now, for the second piece, we are between 0 and what? And 3. And if you look at it between 0 and 3, what do we have? This is a line, right? This is a line. Remember, this is our, like, a y is equals to what? Mx plus b, where b is the what? Is the vertical intercept, and m is the slope. So this is just something like this. It's just going to be a positive line, which is rising, right? Because the y-intercept is going to be what? Is going to be 2. So, but now we have to restrict this line. Let me come down a little here. So this is it. But we have to stay between 2 and what? Between 0 and 3. So at 0, remember at 0 we are here, we are in the second piece. So at 0, the value is going to be what? 2. So at 0, the value is going to be 2. So this 2 here is what? Is closed. Don't forget that at 0 is open, so it's fine. Now, we're done with the second piece. So this piece is coming from where? X squared. This one is coming from x plus 2. So for the third piece, before we go into that, when x is 3, you can see that if you put x equals to 3 in the second piece here, this is the second piece. If x equals to 3, the value of y is 5. So it means here is 5 here, right? 5. Okay. Now, the last piece is going to be what? Is when x is greater than what? Than 3. If x is greater than 3, so it means we are coming this way. The value is always 4. So we're going to have it below here. So it's going to be below 5. So let's say 4 is somewhere here. So we're going to have it here. But that here is going to be open. Then we will go sideways. It's a constant function. So we keep going, keep going. So that's it. And this is the third piece where you have the constant. Now, from this graph, we can easily pick what the range is. Um, Look at the first piece. This is the first piece. This is x squared. So you see the range is going to be this way. The range for this is just 0 to where? Infinity. The range for the second piece, which is this one, is just the smallest value of y is what? Is 2. While the biggest value is what? Is 5 when you are at 3. So you have union 2 to 5. Then for the third piece, here you can see it's just a constant 4. So union 4. So you see this is the same thing. And this is nothing but where 0 to infinity. So that is the range. So we can do it either using the first method or the second method. I hope this video on how to find the range of a piecewise defined function is clear. Thank you for watching.